measure progress by firsts, by overcoming barriers. The conquest of Mount Everest was a famous first. So was Roger Bannister's 4-minute mile. Then there's the breaking of the sound barrier. And of course, John Glenn's Earth orbit. Well, we at Polychrome have broken a barrier in the graphic arts industry. New printing systems relying on laser light to convert images into digital data and back into images have been working toward the elimination of film intermediates by going directly from computer to printing plate. As you know, computer-to-plate imaging has been on the horizon and predicted for over a decade. But until now, there has been a barrier. Printing plates just haven't been good enough. And at Polychrome, we came up with the technological breakthrough. The laser scan laser printing plate. Of course, it didn't happen overnight. Polychrome technicians working with our parent company, Dai Nippon Ink and Chemical Company, have conducted extensive research. And together, we achieved the technology goal. We broke the barrier. We made computer-to-plate technology a practical reality. And the heart of the technology was this: a new organic photoconductor called OPC-B. We tested it internally and then looked for a place to test it under production conditions. We demonstrated the plate to the Dow Jones Company, which, as you know, has one of the world's most sophisticated laser facsimile printing systems used to print the Wall Street Journal. The original pages are made up at central regional printing plants, like this one for the Midwest section at Naperville, Illinois. Page proofs are then laser scanned and put into digital form by the advanced system called DowScan. The digitized pages are beamed up to a communication satellite and back to Earth stations at remote printing plants. In the printing plants, the signals go directly to the laser scan plates, completely bypassing film intermediates. The laser scan printing plates are loaded for imaging and processing into a Chemco NewScan facsimile system. Inside the system, a low-powered laser writes the image on the plate. Laser imaging and liquid toner in combination have the imaging speed of films without the extra steps and extra costs. It was on this system that we conducted a test for 6 weeks, 30 consecutive production days, and met all the rigid requirements of printing the Wall Street Journal. The laser scan plate was put into regular production at the test site at the Journal plant in Sharon, Pennsylvania. It is now being used in 5 plants every day, and more plants are being added. The plates can be processed either automatically or manually. After being fused, the plate is washed to remove the organic photoconductor. The plates can be handled in ordinary room light, and after washing, they're treated like any standard offset plate. Because aqueous solutions are used, there are no fumes and no environmental hazards, and no special training or handling is required. Roll-up is simple, and startup time is quick. As a result, there's less paper waste. The technological breakthrough is not only in the laser scanning phase. Just as important, the finished plate is a familiar, ordinary plate. It is aluminum for dimensional stability. It is grained for excellent ink-water balance, which simplifies press control and ensures sheet-to-sheet consistency. It's anodized for long, trouble-free runs. Its toughness is also being successfully demonstrated day in, day out at the Las Vegas Sun in a dilitho application. The key is this. What the lasers will see is extraordinary organic photoconductor technology. What the pressman will work with is an ordinary workhorse printing plate. That, it seems to us, is a sensible advance in technology. We're pleased with the plate, of course, and so is the Wall Street Journal. They see it as important for the future. This new generation of electrographic laser printing plate will likely have a significant impact on laser-to-plate technology in the graphic arts industry in the next 5 years. Those are the words of Frank Breeze, Vice President of Dow Jones Operating Services Group. And Chemco told us this. We certainly feel that LaserScan takes electrophotographic laser plate imaging to a considerably higher plateau. This product sets the standard for electrophotographic plate laser imaging and will likely have a significant impact on the graphic arts in the next 5 years. Stephen Schuster is Chemco's Vice President for New Products. But maybe the most important and rewarding recognition of our technology came in January from another prestigious source, GATF. The Graphic Arts Technical Foundation, GATF, is the major scientific, technical, and educational organization serving the international graphic communications industry since 1924. Every year, GATF gives its InterTech Technology Awards. The awards are granted for innovative technology that is predicted to make a major impact on graphic arts within 5 years. And the technology should be one that has been proven in an industrial application, but is not yet used broadly in the industry. To give you an idea of how important these awards are, here are some of the past winners. As you can see, they include technology giants. In January, the GATF gave Polychrome an InterTech 85 Award for developing the laser scan plate. We're proud of this recognition of our technology. We know that the laser scan printing plate will have an influence. Certainly it will have a strong impact on distributed newspaper printing. But we can expect to see direct-to-plate technology expand into book printing, forms printing, and other business applications. And in fact, laser scan plates are capable of being used even for high-quality magazines. The economic implications are much larger and much more important. The graphic arts industry alone spent $250 million in 1982 in graphic arts supplies, photo typesetting paper, litho film, and chemicals. Clearly, computer-to-plate technology can reduce that figure considerably. Then consider the labor costs, almost $2.5 billion. The elimination of film intermediates can make a big difference in reducing labor costs. We at Polychrome are proud to have been the first to make a major breakthrough in plates for laser-imaged computer-to-plate technology. But we know it's just the beginning. Now that we have opened the door, the entire graphic arts industry and newspaper industry view the Wall Street Journal project as a window on this technology development of satellite transmission, computer-to-plate via laser application. As laser imaging technology moves forward at a breakneck pace, we can expect significant changes. And we, in the imaging materials business, will certainly meet the challenge. We can expect to see costs decreasing and efficiency increasing in applications such as the Wall Street Journal. But this isn't all. In January 1985, the New York Times carried this story. Apple Computer's new laser printer, aimed at the office computer market, might have its greatest impact on another area, the traditional typesetting and printing industries, according to analysts. This means that laser printing systems are not reserved to the $250,000 price range, but are already making inroads into the office computer market. According to Jonathan Siebold, a respected industry analyst, what Apple has done at a strikingly low price is to put this laser technology into a product anyone can buy. It's going to turn the industry upside down. This is an important trend. For the first time, the small printer will be able to do pagination on a personal computer and send the digital information to a laser which writes directly on a plate. This means that thousands of printers will have access to computer-to-plate technology. This is the door that Polychrome has opened. Just one more example of our leadership in graphic arts. We realize that others are jumping on the bandwagon, that everybody else's technical staffs are already trying to improve on our breakthrough. But you can depend on this. We at Polychrome intend to stay in the forefront of laser plate technology. We're proud that we're the team to beat. Thank you.